Hello and welcome to the 3x2 memory circuit walkthrough. My name is Mohammed Hessam and I'll be guiding you through this walkthrough. So first, let's discuss what the function of the circuit is. The circuit, as you can see on the screen, is a 3x2 memory circuit. The circuit itself is divided into 5 main components. In order to initiate the circuit and test for its functionality, we need to work around with 3 main leads: the address lead, the data leads, and the read and write input. Now let's take up the address leads first. For conventional purposes, I have highlighted my address leads in the yellow box. Now a person may ask, what is the purpose of the address leads? Well, here is the answer. To start my answer off, I want to indicate this very important detail, the title of the assignment itself, which is 3x2 memory circuit. Now the circuit basically has 2 bits of data in 3 memory locations. Now 2 bits of data are known as one word, therefore it stores 3 words in 3 different locations. Allocation of the 2-bit data in one of the 3 memory locations is where the address leads come into play. The input for the address leads, the memory location will be chosen. For the first situation, if the first address lead is 1 and the second one is 0, then the first address bus will be chosen. In the second situation, if the first address lead is 0 and the second one is 1, then the second bus will be chosen. And for the third one, if they're both 1, then the third location will be chosen. This is in correspondence to the binary digits. It is also important to keep in mind that none of the data leads can be 0 or 0. This is due to the fact that none of the 3 AND gates will initiate, therefore the whole circuit will not start. Alright, now that we have chosen our address bus, let's see what the data leads do. Okay, so at this point, one of the address bus basically initiates the clock of the commercial D flip-flop. Now since the commercial D flip-flop's clock has been initiated, since the positive edge has been triggered, it's basically going to see that what the data leads are and program according to that. Data leads are basically connected directly to the data of the commercial D flip-flop. Now how the commercial D flip-flop works is that if it's fed a 0, then the output is going to be a 0 as well through the Q. And if it's fed a 1, then the output is going to be a 1 as well. Now when wearing the commercial D flip-flop on the circuit itself, it's really important to keep in mind that both the preset and set pins are both in the positive. Now what this does is that it puts the commercial D flip-flop in the set mode. Therefore it basically, whichever state it is in, is going to keep repeating in that state. It's not going to change. Okay, so on the circuit itself, basically when the data bit 0 is 1 and data bit 1 is 0, then the red light will only turn on. This can be demonstrated through crocodile clips as well as the circuit itself. When the second data lead is 1 and the first one 0, the green light will turn on. This can be demonstrated through the circuit and the crocodile clips. Now finally, when the first and the second lead are both in positive, both the lights will turn on, green and red. This can be demonstrated by the circuit and crocodile clips. Now, as I already mentioned before, Qs are basically the outputs from the commercial D flip-flop. Now where the Q outputs go are a set of AND gates. Now basically there are 6 AND gates in the set. The first pins of the AND gates are powered by the commercial D flip-flop's Q output, while the second pin is powered by the address bus. Now these AND gates connection with the address bus basically only allows a certain data bus to be functional. And because only that certain data bus is chosen, the memory will be only stored there and nowhere. Okay, so from this point on, the role is solely played out by what I think is the most influential and the important part of the circuit, which is the read and the write input. So without any further delay, the read and the write input. Now for my conventional purposes, I have highlighted the switch or the read and write input in the red box as shown in the diagram. Okay, basically the read and write lead is connected to 2 main parts. The first main part is that it's connected to a NOT gate. Okay, so basically when you turn the switch on or give the NOT gate an input of 1 and as a result it gives an output of 0, the AND gate is basically shut off. Now what this does is that it gives an output of 0, basically turning off the clock. Now because the clock on the commercial D flip-flop has been turned off, the whole system has gone from a synchronous mode to an asynchronous mode. Now because the whole system is always on set mode, no matter how much you change the data leads, the same output will be given again and again and will not change. Now this is also helped by the fact that the clock is on a negatively charged trigger mode, so basically no matter how much you change the data, it's not going to be able to latch up onto the data, so basically it does not store it anymore. Now, these two systems essentially combine together and store the data in the specific address bus location. This now can only be changed when the whole system goes back to the write mode, then the data leads are changed, and then it goes back to the read mode. Then the clock is going to go in a positive trigger mode again, the data is going to be latched up on again, and the whole system repeats. As I said earlier, the read and the write lead, it basically connects also to another section. This section is the second set of the AND gates. The first pin on these AND gates is fed by the third pin on the previous set of AND gates, and the second pin is fed by the read and the write lead. When the lead is 0, these AND gates will not function because they need a 1 and a 1 in order to give an output. A 0 and 1 alone will not help them. But once the switch is turned on and they are given a 1, they are going to start working and giving an output. This output goes into a NOR gate, and these two NOR gates are basically connected to the red LED and the green LED. The red LED will turn on or the green LED will turn on is already predetermined, as I already took up earlier in the video. And this is basically dependent on which data bit is on, and I already took up if it's 0 and 0, neither, if it's 0 and 1, then the green, if it's 1 and 0, then the red, and if it's 1 and 1, then both. Okay, the walkthrough is almost done, except for the fact that I need to take up one more important feature about the circuit. Okay, so the next topic that I'm going to explain, which is the last, is going to give you the true essence of what the memory circuit does. So let's say you choose the third data bus by putting a 1 and 1 in the address bus, and then you store a 0 and 1 through the data bit, so basically turning on the green LED. So now you put the switch on and turn the whole circuit on read mode, meaning that the data is going to be latched up on since the positive edge has been triggered, and the green LED will be turned on. Let's say you didn't turn the switch off, so it's on write mode, and then you change the address bus from a 1 and 1 to a 1 and 0, so basically the second address bus. You then change the data leads from 0 1 to 1 and 1, meaning that when you put the circuit back on read mode, both LEDs should turn on. And so it does, both LEDs turn on. Now you might be thinking that what's so special about this? What makes this function so special that you're talking about or you're about to explain? Now here it is. Well, here's the amazing part. If you just change the address lead from 1 and 0 to 1 and 1 back again, only the green light will then turn on again. Now this is due to the fact that that one word had been saved there and now it's just being retrieved. The specific address bus's clock's positive edge had not been triggered, therefore the new data had not been latched on and the old data had kept being repeating, thus it had been saved. This key feature basically gives the 3x2 its real meaning and its real functionality and its real identity. Well, I guess we have covered everything, and thanks for sticking around through the whole walkthrough. I really hope that explained everything, and yet again, thanks for watching and have a great day.